everyone. So in previous classes, we have started our third topic, that is fluid flow, and in that topic we have seen the various types of fluid flow, right? So now we will start with the next point, that is discharge. That is discharge. Okay. So discharge, it is also called as rate of flow. It is also called as rate of flow. It is called as discharge, or it is also called as rate of flow, and it is represented by the capital Q. It is represented by the capital Q. Right? So, how discharge is defined? So, discharge is defined. First of all, I will tell what is discharge. So, the name itself says us that discharge is nothing but the quantity of fluid flowing per second through a pipe or through any flow. It is nothing but the flow measurement unit. What is it exactly? The name itself, rate of flow, means what? Rate of flow, right? So it is nothing but the flow measurement unit. So how discharge is defined? Discharge is defined as how much quantity is flowing through the pipe. So discharge is defined as quantity of fluid flowing per, you can say per second, or you can say per unit time. Quantity of fluid flowing per second through a pipe or channel. Through a pipe or channel, right? So that is called as discharge. Means how much quantity of fluid is flowing per unit time, right? So that is called as discharge. So this quantity can be measured. This quantity of fluid, we can measure this quantity of fluid in two terms. That is, quantity of fluid can be measured or you can say considered, can be measured. Either we can measure the quantity as a volume or weight, right? So quantity of fluid can be measured either in volume of fluid, or in mass of fluid. We can measure the quantity of fluid in these two terms, volume of fluid and mass of fluid. Now we will see when we have to use the volume of fluid and when we have to use the mass of fluid, right? So already we have seen the types of fluid. In that we have seen compressible fluids and incompressible fluids, right? Or compressible flow or incompressible flow. So what is meant by compressible flow? If the density is not constant or density of fluid varies from point to point, then it is called as compressible fluids. And what is incompressible? If the density is constant from point to point in the flow field, then it is called as incompressible. Means density remains constant always. That is called as incompressible fluid. That we have seen in the types of fluid. Similarly, so as the density remains constant in incompressible fluid, density remains constant in incompressible fluid. In incompressible fluid, we are measuring discharge as volume of fluid per second. As in incompressible fluids, density remains constant, we are measuring the discharge as a volume of fluid per second. Okay, so for incompressible fluids, for incompressible fluids, discharge is measured in volume of fluid per second. Volume of fluid per second. So as we are considering volume of fluid per second, so what will be unit of discharge for incompressible fluids? For incompressible fluids, what will be unit? So that will be volume can be measured as a meter cube per second, or we can measure the volume in a liters also. So it will be liters per second. It will be liters per second for incompressible fluid. Okay. So next we will see for compressible fluids. As here density is not constant for compressible fluids. Okay. As density is not constant from point to point. So discharge from point to point. So discharge will be what? So discharge is mass of fluid. Discharge will be mass of fluid flowing per second. Discharge will be mass of fluid flowing per second. So now, what will be the unit for compressible fluids? As we are considering the quantity, as a mass of fluid. So what will be the discharge? What will be the unit? So unit will be Newton per second. Unit will be mass will be considered in Newton, or you can say kgf per second, right? Kg per second. Okay. So now we will see the formula also for incompressible fluids. How the discharge is calculated? Q is equal to kg per second. Kg per second, right? So how discharge will be measured for incompressible fluids? So Q is equal to, as we are considering only volume of fluid per second, so discharge is equal to area into velocity. Discharge is equal to area into velocity. And for compressible fluids, as we are considering mass of fluid, so here density will be comes into the formula. So density into area into velocity for the flow, right? For the rate of flow, A is what? Area of the channel or area cross-sectional area of the pipe. If we are considering the flow through pipe, then that A will be the area of the pipe. V will be the velocity of flow. For this will be density of fluid. A is the cross-sectional area of pipe, and V is the velocity of flow. Right? So that will be the overall about discharge and rate of flow. It is nothing but the measurement unit of the flow, right? So quantity of fluid flowing per second through the pipe or channel. Okay. So that quantity can be considered as volume of fluid, or it will be considered as mass of fluid. So for incompressible, as density is constant, so it is area into velocity. And for compressible fluids, as density varies from point to point, we are considering mass of fluid. So Q is equal to density into area into velocity, right? So this is rate of flow. Okay. So that point is very important. So remember this concept. Now we will move on to our next point, that is continuity equation. This continuity equation is based on this discharge or rate of flow. Okay, continuity equation. Continuity equation, right? The continuity equation is what? equation based on conservation equation based on conservation of equation based on principle of equation based on principle of conservation of mass conservation of mass equation based on principle of conservation of mass, then it is called as, if the equation based on principle of conservation of mass, then it is called as continuity equation. So what we can understand from this, based on principle of conservation of mass means as per the continuity equation or as per the continuity equation, if we are considering a channel or a pipe, if we are considering this tapered pipe, we consider a tapered pipe. So as per the continuity equation, what continuity equation says, whatever the discharge or whatever the rate of flow through this pipe will be constant at each point, right? If we consider one channel, so discharge will be remains constant, right? Discharge will be remains constant throughout the channel or throughout the pipe. So that is means it is based on the principle of conservation of mass. Based on the principle of conservation of mass. Now we will take that example, right? So if you have considered one channel, we will take here two sections. This is section 1 and this is section 2. Section 1 and section 2. Now we will consider some properties at section 1. If we are considering this, that is the density. So rho 1 will be density at section 1. Density at section 1. Now we will consider area as it is tapered pipe. Area at section 1 is less than area of section 2. So the areas are also different. So there will be cross-sectional area at section 1. And next we want velocity. That will be velocity of flow at section 1, right? So density, area and velocity. Similarly, rho 2, A2 and V2 will be the corresponding values at section 2. Means what? Rho 2 is the density at section 2, area is the A2 is the cross-sectional area at section 2, and V2 is the velocity at section 2, right? So next, as per the continuity equation, what I have told, as per the continuity equation, rate of flow at every section is, or at every point throughout the channel is same. Now we have considered the two sections. So rate of flow at section 1 is equal to rate of flow at section or discharge at section 2. At section 1 and section 2, discharge will be the same, right? So now we have two formulas for the discharge. If it is a compressible fluid, the formula is different for the discharge, and if it is incompressible fluid, formula is different. We will consider first of all compressible fluid. We will consider the fluid flowing through the pipe is compressible fluid. Compressible fluid, nothing but the gases. We are considering gases as a compressible fluid and liquids as a incompressible fluid, right? So for compressible fluids, what will be our rate of flow at section 1? It will be rho 1 A1 B1. Rho 1 A1 B1 will be the mass flow rate, or you can say mass of fluid flowing per second at section 1. So that will be the discharge. Similarly, rate of flow at section 2 will be rho 2 A2 V2. Mass flow rate at section 2 will be rho 2 A2 V2. So that will be your continuity equation. That will be your continuity equation for the compressible fluids. Now, if we are considering the incompressible fluids, if we are considering the incompressible fluids, if we are considering the incompressible fluids, what will happen? The formula will be as for incompressible fluids, as for incompressible fluids, rho 1 and rho 2 will be constant. Means what? For incompressible fluids, density of fluid does not vary from point to point. The density of fluid will remains constant throughout the channel, throughout the pipe. So that density 1, density 2 will be get cancelled because these are equals. Rho 1 is equal to rho 2 as the fluid is incompressible. So what we will get the formula? A1 V1 is equal to A2 V2. A1 V1 is equal to A2 V2. If we increase the sections, if we are consider the number of sections, our formula will go on. It will be A3 V3 is equal to A4 V4 is equal to A and B. Right? Is equal to A and B. So what continuity equation? Important point is what? Continuity equation is based on principle of conservation of mass. Continuity equation is based on principle of conservation of mass, and what it says, whatever the discharge to the pipe will remains constant throughout the pipe. Which remains constant will be the throughout the pipe. What will be the discharge at section 1? Will be the discharge at section 2. Will be the discharge at section 3. Will be the discharge at section 4. What it says? In short, the discharge will remain constant. Discharge will remain constant. So this is continuity equation. This is very important as numerical point of view. It is very important. This is for the compressible fluids. And this is for the incompressible fluids. Okay. Thank you.